The future of transportation is electric. This isn't just a slogan, it's a fact. In the last financial year alone, EV sales in India skyrocketed past 2 million units, growing over 15% year over year. And this is just the beginning. The market is projected to grow over 40% annually. But this massive growth is being held back by two critical unsolved problems: a problem for the consumer and the problem for the city. First, the consumers. For millions of potential buyers, the number one problem is the range anxiety. Research show it's the primary roadblock for not buying an EV. Drivers are terrified of being stranded on a trip, not knowing where the charger is or even if it is available or not. Now, let's look at the city planner. They face the second problem, infrastructure uncertainty. India's public charging network is currently supplying only 2.7% of the daily electricity demands from EV. This creates a staggering 97% energy deficit. We are building chargers, but we are building them blind. Planners are investing millions without knowing the optimal locations, leading to a massive imbalance. Our project, EVision, is a unified dashboard that directly solves both these problems. We provide a data-driven solution for the driver and the planner to show how we solve the driver's range anxiety. I will hand it over Chintamani.
Hello everyone, I am Chintamani Manisha Namdev Chaudhary, here to explain the very first problem that is faced by an EV user, that is range anxiety. An EV user is always anxious regarding will his vehicle reach the destination safely or not. Will he receive enough charging point in his path or not? For the same, we have designed this EV trip planner that plans your long distance EV journey with perfection peace of mind. For the same, what EV specifications we require are battery capacity, EV range and average speed. Battery capacity help us to decide the total charging time. We also assume that the charger that you will get during your journey will be 50 kilowatts per hour on average. The EV range help us to decide a safe range after which your particular charger has to be found. Average speed help us to decide at what rate your battery will be drained. Then we take your start city and your destination. For now, we have set it by default to Nagpur and Pune. The battery capacity is taken 60 and can be taken anything in between 30 to 100. EV range can be taken anything between 100 to 500. With the help of slider, you can adjust it. I have taken it as 250 for now. The average speed can be taken anything between 40 to 120, for which we have taken 80 kilometers per hour as our average speed. As soon as you click on planned trip, the very first thing has been given is the latitude and longitude of Nagpur and Pune to open route service to fetch the route between Nagpur and Pune. Once we have route between Nagpur and Pune, it's stored in the array, and then using geodist library of Python, we start calculating the distance after which the safe limit is hit. For now, our EV range is 250, so 80% of it will be somewhere around 200 to 210. Once the safe limit is reached, you will be given a charger around the 40 kilometer diameter of the point you're standing after completion of your safe limit. We have given you total distance, total time, the driving time that will be taken at the charging stop that you will be going through. So there will be 3 charging stops. The driving time is 11.2 hours and 14.2 hours is total time which has added your charging time into it. You have also gotten a map, the complete map visualization of start point, that is Nagpur. Then you will be having your first stop, second stop, third stop and your destination. Scrolling down to it, you have a perfect map visualization. Going up next, stop by stop detail. Here we are having a complete summary of your stop from where you will be starting and what the destination and what are the chargers you will encounter in between. Once you click the drop down for a particular chargers, you'll get the top 5 charger nearby to the location where you complete your safe limit. As you can see, charging stop after 201 kilometers. There are 5 chargers that have been recommended, and if you click on the map links, it will take you directly to that chargers on Map My India website. For finding nearby places or nearby chargers, we take Map My India API. As I told you, we have a very unique feature that finds POI, point of interest. What will you do while your car is charging? So we provide you with 3 options that you can do while your car is charging: food, cafe or attraction. So attraction basically refers to all the popular sightseeing or tourist places that are located in that. For this, we have taken a very small distance. We have taken a 4 kilometer radius, a 4 kilometer diameter, in which you will be given things. Ki, okay, what is there in 4 kilometer to explore? You can explore by walking or taking a rickshaw or something while your car is charging. There are cafe have been recommended, food places have been recommended, and top 3 of each and everything will be shown up to you. But what if there is nothing as such attractive in there? So it will also mention ki no attraction place found nearby, and rest you can see as similar to the previous format. Top 5 chargers, top 3 food places, the cafe that it has got, and same for the last one too. This complete solutions help a particular EV user to plan his trip wisely and safely and without any hassle. Happy travel, guys.
Now we'll move to the EV infrastructure management part of our EVision project. In real-world scenarios, the number of electric vehicles is increasing much faster than the availability of charging stations. Cities often face uneven distribution. Some areas have more chargers than necessary, while others experience long waiting times and range anxiety. Planning new stations manually becomes inefficient and expensive because it relies on outdated surveys and guesswork. Our module solves this problem by analyzing EV charging station data and helping city planners identify where new chargers should be installed. It acts like an intelligent decision support system that evaluates the existing infrastructure. This is the dashboard for infrastructure management. Here you can see 2 visualization outputs, the OpenStreetMap view and the K-means clustering graph, along with the structured station data displayed in the tabular format. To begin with, we can select any major city such as Ahmedabad, Chennai, Delhi, Kolkata, Nagpur, or New Delhi to analyze the charging station clusters. The number of clusters can be selected from 2 to 10, but for an optimal and interpretable solution, we generally keep it to 3. Let's take an example of Nagpur. Once we select Nagpur and run the analysis, the system processes the data and displays the result. The first output is the OpenStreetMap view, where all the EV charging stations in Nagpur are plotted and grouped accordingly to their cluster. This shows how stations are geographically distributed across the city. Next, we have the K-means clustering scatter plot. Here, each point represents a charging station plotted using its longitude and latitude. The stations are color-coded, typically shown in blue, orange, and green, indicating which cluster they belong to. The model groups stations based on geographical distances, so there is no guesswork involved, ensuring efficient infrastructure planning. In the tabular view, we can see the exact latitude, longitude, city name, and the assigned cluster for every charging station. This makes it easier for planners to inspect precise coordinates and understand the distribution clearly. We also provide silhouette score, which tells us how well the clusters are formed. A higher score means well-separated clusters. For EV's infrastructure planning, an approximate score around 0.5 is ideal because we do not want all stations heavily packed in one area. We want them evenly and sparsely distributed across the city. Overall, this module helps identify underserved zones, optimal regions for new chargers, and ensures charging infrastructure is expanded in smart, data-driven manner.